Variance. The objectives: the student will be able to 1. Find the variance of a set of data. 2. Find the standard deviation of a set of data. Variance. Variance is the average squared deviation from the mean of a set of data. It is used to find the standard deviation. Variance. How to find the variance? 1. Find the mean of the data. Hint: the mean is the average, so add up the values and divide by the number of items. 2. Subtract the mean from each value in the data set. The result is called the deviation from the mean. 3. Square each deviation of the mean. 4. Find the sum of the squares. 5. Divide the total by the number of items. The variation formula. The variance formula includes the sigma notation, which represents the sum of all the items to the right of the sigma sign. Sigma: x minus mu all squared over n. Mean is represented by mu and n is the number of items. Standard deviation. Standard deviation shows the variation in data. If the data is close together, the standard deviation will be small. If the data is spread out, the standard deviation will be large. Standard deviation is often noted by the lowercase Greek letter sigma. The bell curve, which represents a normal distribution of data, shows what standard deviation represents. There is the bell curve. One standard deviation from the mean, mu, in either direction on the horizontal axis accounts for around 68% of the data. 2 standard deviations from the mean accounts for roughly 95% of the data, and 3 standard deviation represents 99% of the data. You will go through this in more detail when we study the normal distribution curve. To find the standard deviation, find the variance, the mean of the data, subtract the mean from each value, square each deviation of the mean, find the sum of the squares, divide the total by the number of items, take the square root of the variance. The standard deviation formula. The standard deviation formula can be represented using sigma notation. So the standard deviation is the square root of sigma x minus mu squared divided by n. Notice the standard deviation formula is the square root of the variance. Find the variance and standard deviation. The maths test scores of 5 students are 92, 88, 80, 68 and 52. Find the mean. 92 plus 88 plus 80 plus 68 plus 52 all divided by 5 comes to 76. Find the deviation from the mean. 92 minus 76 is 16. 88 minus 76 is 12. 80 minus 76 is 4. 68 minus 76 is minus 8. 52 minus 76 is minus 24. square the deviation from the mean. 16 squared is 256, 12 squared is 144, 4 squared is 16, minus 8 squared is 64, minus 24 squared is 576. Find the sum of the squares of the deviation from the mean. 256 plus 144 plus 16 plus 64 plus 576 is 1056. Divide by the number of data items to find the variance. So 1056 divided by 5 is 211.2. Find the square root of the variance. The square root of 211.2 is 14.53. Thus, the standard deviation of the test scores is 14.53. In other words, the average away from the mean, which was 76, is 14.53. A different maths set took the same test with these 5 test scores: 92, 92, 92, 52, 52. Find the standard deviation for this class. Find the mean, subtract the mean from each value, square each deviation of the mean, find the sum of the squares, divide the total by the number of items, which comes to the variance, take the square root of the variance, which is the standard deviation. Again, the mean is 76. Find the deviation from the mean, square the deviation from the mean, find the sum of the squares, which this time comes to 1920. Divide by 5 because there are 5 data sets, so the variance is 384. Find the square root of the variance, so the square root of 384 is 19.6. Thus, the standard deviation of the second set of test scores is 19.6. You can analyse the data if you know the variance and the standard deviation. Consider both sets of scores. Both classes have the same mean of 76. However, each class does not have the same scores. Thus, we use the standard deviation to show the variation in the scores. With a standard deviation of 14.53, the first class and 19.6 for the second class, what does this tell us? With a standard deviation of 14.53 for the first class and 19.6 for the second class, the scores from the second class would be more spread out than the scores in the second class. Class C. Estimate the standard deviation for Class C. Class C has scores of 77, 76, 76, 76 and 75. Will the standard deviation be less than 14.53? Will the standard deviation be greater than 19.6? Will the standard deviation be between 14.53 and 19.6, or cannot make an estimate of the standard deviation? Which of those do you think is correct? If you look at those data sets now, it would be answer A. The scores in Class C have the same mean of 76 as the other two classes. However, the scores in Class C are all much closer to the mean than the other classes. So the standard deviation will be smaller than for the other classes. Summary. As we have seen, standard deviation measures the dispersion of data. The greater the value of the standard deviation, the further the data tend to be dispersed from the mean.